So let's begin by talking about the nth root here. So let's begin by something really, really basic, right? Let's start with just some straight up examples. If I give you 3 squared is equal to 9, that's a true statement, right? Everybody agrees with that? Yes, okay. So what does this mean? This means that 3 is the square root of what number? 9, very good. Okay, so if I do 3 to the third, what do I get? I get 27. So 3 is the what? Cube root of what? Of 27. Good. Okay, if I do this, if I do 3 to the fourth, what number is that, everybody? 81. So therefore, 3 is the what? Fourth root of what number? 81. And so I could keep going on and on all day long. You guys agree with that? You guys still with me on this? Say yes or something? Yo, everybody's good. Okay, so I'll make sure everyone's on board. Okay, so what can we say here? Well, it seems that corresponding, so COR, corresponding shorthand rem, corresponding to every power, there is a root. There is a root. So corresponding to every power that I keep going, there seems to be a root. So this pattern here, right, this pattern suggests what an nth root is. So it suggests that if we have this, so if we have a to the n is equal to b, just like I had up in before, they're like 3 to the fourth is 81 and 3 to the third is 27. If a to the n is equal to b, then what can we say? Then it must be true that a is the nth root of what? Of b. There you go. So that's what we're trying to act. That's basically what we're just saying here, right? That's what an nth root is. If a to the n is b, then it must be that a is the nth root of that b. And we saw these examples right here, right? 3 squared is 9, so 3 must be the square root of 9. 3 to the third is 27, so 3 must be the cube root of 27. So corresponding to every single power, there must be a root. So that pattern suggests to us that if a to the n is b, then a must be the nth root of b. All right, let's talk about notation. I have 3 symbols, or I have 3 parts that you see on the board right now. I have an n, I have a square root, and I have the a. I'm going to give you 3 words, okay? One word is going to be index, one word is going to be radical sign, and one word is going to be radicand. Does anybody know which one is which? Start off with the easy one. What do you got? N is the index. Very good. So the number out here, this represents our index. All right? What does the A represent? Is that the radical sign or the radicand? Yeah, it's not the radical sign. Everyone knows that one is. So this is the radicand. Very good. So obviously, therefore, this must be the radical symbol. All right, so we got the radical symbol. Okay. So there's some notation. The most important one that we're going to be using today is the index, talking about that index out there. So when I'm referring to the index, I'm talking about that number that sits right outside top left of that square root symbol. All right, so we are interested in finding all real roots, and then for part A, we're going to find all cube roots to the following numbers here. So I'm going to give you this number, 0.008. I am interested in finding the cube root of this number. So what am I asking you here? Well, according to our definition, we're looking for a number that when we cube, we get 0.008. All right, right now with your partner, see if you can find what that number might be. All right, what did you guys come up with? Yeah, 0.2 is a cube root of 0.008, okay? Is everyone on board here? Because that's the number that which I cube back and get that. Okay, number 2, I'm going to give you this number. The number I want you to do is negative 1,000, okay? So find all cube roots for negative 1,000. What would it be? So what are we looking for? We're looking for this. What number can we cube back to get negative 1,000? Anybody got one out there? Yeah, negative 10. That is the cube root. Negative 10 is the cube root of negative 1,000. Okay, try number 3, 1/27. So I'm looking for all real cube roots. So what am I looking for? I'm looking for a number such that when I cube it, I will get back 1/27. Anybody got one? Yeah, it would be 1/3, right? 1/3 is the cube root of 1/27. Okay, here's number 4. I want you to find all fourth roots. Okay, I want you to find all fourth roots. Number 1, the number 1. Find all fourth roots for the number 1. So what am I looking for here? I'm looking for a number that when I raise it to the fourth power, I would get back the number 1. Anybody got an answer? Yeah, 1 would work, but what else would work? Negative 1 to the fourth would also work because negative 1 to the fourth power gives me back 1. So there are 2 real roots for, or fourth roots to the number 1, namely 1 and negative 1. Is okay with that part? Okay, good. Okay, find all fourth roots to the number 1681st. So what am I looking for? I'm looking for what number, when I raise to the fourth power, would give me back 1681st. Yeah, one of them is 2/3. What's the other one? Yeah, negative 2/3 is the other one, right? Gives us back 1681st. All right, I would like you to explore now on your own without a calculator. Try and find all the real roots to each of these problems, A, B, C, and D, on your own with a partner, okay? Right now, all the real roots. Okay, let's discuss. Who got part A? Who wants to shout out? Just tell me what you got. Yes, I got an answer of negative 2. Okay, the reason that one is negative 2 is because negative 2 cubed will give you back negative 8, right? So let me use a different color here for you. You guys, anybody get something different for that? So we got negative 2 for that, okay? Because when I take negative 2 to the third power, it gives me back negative 8. So that must be the answer. Okay, B, what'd you guys come up with? 0.2. Yeah, this is 0.2. Okay. Now it's not plus or minus part 2 because this number represents the positive root. Okay? This is the positive root of 0.04. So the only answer is 0.2. Okay? Because there's no negative sign in front of that. This represents that number. The square root of 0.04 is 0.2. That's what that represents. Okay, going one direction. Part C. What did you guys come up with? There are no real roots to this one. Is that what you guys meant to say? Is that what you guys said? There are no real roots for this because there is no number to which I could raise the power of 4 to get back negative 1. That does not exist in the real number system. Yeah, this is the square root of 4, which happens to represent the answer of 2. Okay? The principal square root of 4 is 2. The positive root of 4 is 2. That's what that number represents. I'm glad you guys did not put negative 2 in that one, okay? So it is not always the case that we just simply cross these out. Because that's what maybe other algebra teachers may have shown you in the past. That's not a true, real, verdant understanding of what that actually means. So this is negative 2 squared is 4. The principal square root of 4 is 2. Okay, on your own, you try. Here are 4 problems. I'd like you to find find all real numbered roots. Okay, all real roots. Ready, set, go. Okay, what do you guys do for part A? Yes, this should be negative 3 because what number do you cube back to get negative 27? That'd be negative 3. Okay. Part B. This would be no real root. How come? Because there is no number I could raise to the power of 4 to get back negative 81. Okay? There's nothing I can think of. Okay, this one is the number what? This is what? This is the number 7. This is 7, right?
He's the intermediate step.
Oh, intermediate step, yeah. Okay, yeah, I agree. The answer is 7 though there, and not negative 7. That's not what that means. Okay, D, what do you guys have?
No root.
There is no real root. Okay, you guys feeling good with this so far?
Yeah.
Okay, the nth roots of nth powers. This is going to lead us into the conversation of how we simplify radicals that have variables in them, all right? So for any real number A, if we have the nth root of a to the nth. Now, it's not the case, as we saw up above in the 2 examples, in the previous examples, it's not simply the case where we just cross off the ends and we get a. We need a more sophisticated understanding of what this says. So the nth root of a to the n is going to be a if your index n is odd. Okay, so if that index is an odd number, we don't need to worry about it. But since we're finding principal square or principal roots, it's going to be the absolute value of a if n is even. Alright? So this is a more in-depth understanding for what it means to be nth roots of nth powers. So I'm going to make a little note over here, okay? So we must include the absolute value bars when n, our index, is even. Okay, we must include that when n is even, and we must omit when n is odd. Alright, so that's a little part that goes with this understanding. When you're doing your homework and you're checking your answers, some of the answers are going to have absolute values in them and some aren't. And this is the reason why these absolute values are in there. We're going to do a bunch of examples to try and hash out all this confusion. Are you guys okay with this so far? Alright, let's go ahead and simplify the radical square root of 16x to the 8th. Now, we've got a, what's our index? Our index is what number? Our index is 2. That's an even number. So we're going to include absolute value signs when it makes sense for us because our index is 2. The number that's sitting on the outside is even, so we're going to include this. So the number that's sitting here is the number 2, even though that we don't write it. Everyone still with me, though? Alright, so when I learned how to do this, I was taught to break this up as square root of 16 and then square root of x to the 8th. You guys do the same thing? Okay. Now, I'm looking for an index of 2, so I want to create powers of 2 in the radicand. So that means that if my index is 2, I want some number that I could square. What number would I square to get 16? 4. Okay, good. If my index is 2, I want some number that I could square to get 8. So what number would that be? X to the 4th. You guys understand what's going on with that? You guys good with that part? Okay. Now, alright, according to our definition, if I have an even index, I need absolute value bars. So this is going to be the absolute value of 4. And this is going to be the absolute value of what? X to the 4th. That's what that says. Okay? Well, since I'm multiplying these two things, that's just the absolute value of 4x to the 4th. Right? You guys okay with that part? But let's think about this for a second. Alright? Let's take a look at this. What is the absolute value of 4? It's guaranteed to be a 4. So I'm going to say that's guaranteed to be a 4. What is the absolute value of any number raised to the 4th power? Let's say if it'd be positive, right? Because let's say my x is a positive number. A positive number to the 4th power is guaranteed to be positive. Let's say that my root is negative. Negative to the 4th power will also be what? Positive. So therefore, I don't need my absolute value signs in the end. So the last answer and final answer for me is just 4x to the 4th. Okay, let's do the cube root of a to the 6b to the 9. Okay, before we begin, ladies and gentlemen, what's our index?
3.
Our index is that even or odd? Odd, so we don't need to worry about absolute value signs. You guys good with that part? All right, cool. So I'm going to break this up as the cube root of some number to the 3rd. That'd be great. Times the cube root of some number to the 3rd again. Because I want my index and I want my power to match. So what would I raise to the 3rd to get a to the 6th? A squared, good. What would I raise to the 3rd to get b to the 9th? B to the 3rd, very good. The cube root of a squared to the 3rd is just a squared. The cube root of b cubed to the b cubed is just b cubed, and that's my answer. Easy, medium, or hard? Easy. Okay, good. Let's try one that's going to have an absolute value in it. All right, let's do 4th root x to the 8 y 12. What's my index, ladies and gentlemen? Even or odd? My index is the number 4, which is an even number, so we're going to have absolute value signs, okay? So we're going to do the 4th root of some number raised to the 4th times the 4th root of some number raised to the 4th. So what number would I raise x to the 4th in order to get x to the 8th? X squared, very good. And then y to what number to the 4th would give me x to the 12th? Y to the 3rd, very good. Okay, now, this is the absolute value of x squared times this is the absolute value of y cubed. Okay? Now let's look at these two statements that I have together. The absolute value of x squared, is that always going to be x squared, sometimes going to be x squared, never going to be x squared? It's always going to be x squared no matter what x is, right? No matter what root is. So this is x squared, and I keep the absolute value on the y to the third. Because that part guarantees, it ensures we have the positive root when y cubed is negative. That's what that ensures. Okay, 3 individual U tries. I will give you a hint. Some of your answers will have absolute value bars in them. Okay, so I want you to simplify, use absolute value bars when necessary. All right, let's go for part A. Who wants to tackle part A? Anybody out there? All right, yeah, Rachel, what'd you come up with? Square root of 9 squared, and then square root of x squared squared? That? Okay, then what'd you do? Yeah, okay, so that gives us absolute value of 9, absolute value of x squared. So what's the absolute value of 9 always going to be? 9. What's the absolute value of x squared always going to be? X squared. So our answer is just 9x squared. Everybody got that right? All right, good. Part B. What do we do here? Anybody? Yeah, go ahead, Jake.
So you have to say 3 and then add a to the something to the third, so that becomes 4, and then b to the fifth.
B to the fifth, all to the third?
3.
Okay, good.
And then a to the fourth is always going to be a to the fourth.
Yep.
And then you have to put b to the fifth in absolute values because it could be different.
Not this one, right? What's our original index? Our original index is the number 3. 3 is an odd number. According to our rule, if it's odd, we do not need the absolute value. Okay? So this answer should just be a to the fourth, b to the fifth.
So if the original is odd,
Yeah. Part C, anybody want to tackle it? Okay, what'd you do?
I got x cubed.
Fourth root of x to the third, all to the fourth power, times fourth root of y to the fourth, all to the fourth power. Okay. Now our original index is even, so we have potential for absolute value, right? So this means we have absolute value of x to the third times absolute value of y to the fourth.
And then you just keep the x.
Right, exactly. Y to the fourth is always positive no matter what we do, but depending on the root of x to the third, one can be positive, one can be negative. So we want the principal root, so the positive one. So our answer should be y to the fourth, absolute value of x to the third, or you could have written it the other way, absolute value of x to the third, y to the fourth. So either one of those will guarantee we're taking the principal root of that answer. Does that make sense to you?